Okay, perfect. Then welcome everyone to our webinar today about our new application, the Shipment Flow Optimizer. The webinar has actually the title, How to Monetize the Hub versus Direct Dilemma. So like I mentioned already in our last webinar about the Lockup 6.0, we will have actually 2 additional webinars to go in more detail about our new applications. Our 2 new applications. One application that I want to cover actually today is our Shipment Flow Optimizer app. Like I mentioned already, the Shipment Flow Optimizer app is one of the apps in our premium tier plan. And actually, the Shipment Flow Optimizer app is also the first app in our new app category. So we have one additional new app category, the Network Flow Optimization. Yeah, and this one we actually want to cover today. Therefore, I actually prepared an agenda. So today we will have more time, so we can really go in detail in this application. And I wanted to structure the session today like this. First of all, I want to give you a short overview about the Shipment Flow Optimization app itself. What is the use case behind, and what is actually also a time-space network that is actually used in this application. So this is more a bit a theoretical part. And then I thought, let's try to explain the application with a concrete use case of the automotive industry. So we will take a look at a bit more complex case, also more complex case than in the other webinar from Lockup 6.0. We will take a look at the automotive case with multiple suppliers, warehouses, and also then 2 factories. It's about the inbound for these factories. There I will quickly explain you first the use case. Then we will actually use then this use case to explain you then also the input structure and the logic, because the use case itself is quite big. And the case study behind, that's why I also extracted a really small example. And on this small example, I want to explain you how actually different delivery periods are influencing the decisions that is actually made by the optimizer. So therefore, I prepared a small example. And then we will actually make a deep dive in the use case itself with all the results. And based on then we will also cover actually our new dashboards that we have for the application in detail based on this use case. And then we have an additional Q&A session like always. But feel free, if you have any questions, you can also directly ask them like always in the group, and we will directly try to answer them. And most likely the most important one, if we have enough time, we can pick them also up at the end of the session. Okay, perfect. Then let's directly get started with the overview of the Shipment Flow Optimizer app. I prepared here actually a quick topic where I want to give you some theoretical background of the optimization itself. But before I start with this, I just wanted to mention, what does the Shipment Flow Optimization app do? Like the name already says, we are actually optimizing shipments, and we are actually optimizing these shipments through an existing network. So this means the network is kind of fixed. How the shipments are actually routed through this network, this is actually the decision what is actually done. And it's really important to understand that we don't only decide through which hubs is a shipment routed, we actually also decide when are the shipments shipped. So this when component is a really important part here, because this is actually also new. And therefore, that we can actually do this kind of decision, we need a time-space network. I will explain you in a second later what is the time-space network. Let me quickly just add here the laser pointer. Before I jump into this time-space network, I wanted to come to this network modeling back. We have the possibility to model multiple kind of networks. So we can, for example, model cases like here the direct shipment. So we have here suppliers and customers, and we have here the direct connection. We can also model a hub and spoke. This means we go from our suppliers first to a DC, to a warehouse, and then to our customers. And what we will actually do in our use case, we will actually combine the hub and spoke with the direct shipment. So you can actually also have both approaches in there. What is also new in this application, you can also have actually a multi-echelon case, right? You are not only limited that you only have suppliers and then, for example, a warehouse and then the customers. You can, for example, model also additional steps in between. You can go from the suppliers to the central DCs, and then from central DCs to regional DCs, and then to the customers. So you are really free how to set up actually the network and how it actually also fits exactly to your use case. That's why we are actually offering you this flexibility. And now let's actually come back to this time-space network, because what we are deciding here, we not only decide how we route the shipment through your network, we also decide at which time we are routing the shipment through. And this is also a really important part to actually achieve later on this consolidation perspective. We need to consider the time. And how this is actually done from a theoretical perspective, each of these nodes here in our network that we are model are represented in nodes for the solver itself. And because we have the time period, these nodes don't only exist in one period, like in a static network, it actually exists in multiple periods. And if you, for example, want to transport something from this warehouse, from this location A to the location B, we need, for example, a certain amount of time. So in this example, we need exactly one period to transport something from A to B. This is why the optimizer has only an edge between these two nodes. There is no edge from A to B in the first period, because this would be not possible in this network because of the time constraints. So maybe one word, sorry, I forgot this. A period is actually an abstract number, but to make it simple, in our example, one period is 1 day. So if you want to model the shipments for a whole week, you would, for example, have then seven periods, or you could also have 5 if you only want to consider the weekdays. But this period could be also half a day, or it could be also theoretically 1 hour. Therefore, I just want to mention, as you can see, as more periods you have, as higher is actually also the complexity in the network itself. So we would really recommend break it down to a use case that is also relevant for the reality itself, right? It does not make sense to model it on an hourly basis, because this will make just the complexity is so high that you have actually then problems with the solving time. Yes, so this is actually this theoretical part behind this application, this time-space network. Now, let's quickly take a look which kind of decisions this application actually does. Therefore, let me go to the next slide. What I will also show you then later on, give me 1 second to get the pointer back. We will make the decision in our example, does it make more sense to go directly from the supplier to a factory, or does it make more sense to go via a hub? And then this decision is actually driven by multiple factors. So one of the factors is for sure actually the consolidation, right? If you have the potential to consolidate something in a hub, it is then less expensive, because the second leg here you can drive then together with multiple shipments. So this is one of the drivers that we will actually cover also later. Additionally, what we will also do, we can have multiple transport modes. I specifically call them transport modes, even if I have here 3 different trucks. We can have a small, medium, and large truck, like we will also have later in our use case. But we also need to consider, we could also have a transport mode, for example, a sea shipment compared to an air freight shipment, right? Even if the origin and destination is from the same A to B, right? For example, an air freight shipment is much faster, so it has a different service time, but most of the time it's also much more expensive than a sea shipment. So the optimizer can also decide, and actually, does it make more sense, or do I have to use an air freight shipment because of the time constraints, or can I use a sea freight shipment to reduce actually the costs? when we make this decision here to go through warehouses, we also have the possibility to consider in the warehouse then, for example, the utilization. So this means how much can you handle in this warehouse in a period, and how much can you also store in this warehouse. This will be also part of the optimization. And then for sure, we are actually deciding the shipment route, right? Or how will this shipment will be routed through your network with which consolidation. And this is all then, like mentioned before, it's in a time-space network. This means if you have, for example, delivery that are time sensitive, the optimizer will also choose maybe the more expensive transport mode if it needs to be done. Otherwise, if you cannot fulfill the time constraint. And I think this topic with this multi-echelon part I mentioned already. So now this is already everything what I want to show you today regarding the theoretical part. Let's maybe quickly jump back to the agenda. The next part, I actually want to explain you this based on an automotive inbound case. And the automotive case, what we are actually modeling, I want to explain you directly on the map. So let's directly jump to explain this automotive case based on a map I actually have prepared. So let's make this a bit simpler and first hide all the different layers, because as you can see, there are quite some layers in there. The map that I'm actually showing here is actually the result of the shipment flow optimizer later on that we will calculate. The only thing what I changed to the result, I just added some additional icons in there. If you're wondering if you run it on your side, to make it easier to explain. So our automotive case is actually not only automotive, it's also actually a truck case. So in our use case, we have actually two factories. We have a factory in Wörth that is close to Karlsruhe, and we have a factory in Sindelfingen. So this factory is relevant for the car production. This factory is relevant for the truck production. And this, the goal is we have to bring all the goods from our suppliers to these factories. So we have actually many suppliers in the different areas, just to highlight you all the suppliers. So there are multiple suppliers from truck and from cars in different areas in whole Europe. So now we have the possibility, because it makes sometimes sense to consolidate these inbound shipments. We also model here 3 additional consolidation hubs. So we have one consolidation hub in Czech, then we have one consolidation hub in Germany, and we have one consolidation hub in the south of France. So this means if we just enable a couple of suppliers again to get all the locations, then we have now 2 options how to bring actually this goods to our factories. And so one option is the direct shipment, right? So we can either go from the suppliers directly to the factory. This is now to the factory of the car production, right? This is this one layer. And here, this would be the direct shipment to the truck production. I always directly disable it, that it's more visible. And the second part is this indirect lane. So the indirect lane would be we first go from the suppliers to a hub, and then we go actually from the hub to the factory itself, right? So all the lanes that are actually visible or activated are actually the lanes that are later used in the example. That's why not all connections are displayed. So, but this is actually our use case that we actually want to solve. And our optimizer will solve this in a way that it's the most cost efficient way to consolidate it and to fulfill still all the time restrictions. So this is actually it regarding the use case. So now I want to, let's quickly jump back to the agenda. The next part would be that we take a look now at the input structure. And this one I will mainly do also based on the small example. The main tables of the app itself, I will still explain quickly on this use case, and I will also jump back how this is actually modeled here. So I will come to the small example that is actually just 2 shipments out of the big example. I will come to this one later. Let's go to the bigger example before we actually jump in. The Shipment Flow Optimizer here is actually also a new color because it's in this new category. If you cannot see the application, please go here under Modules. Then here it's the Network Flow Optimization, this new category, and just enable the star. So if you have currently only the Pro subscription, you have the possibility to also run the application with the sample data. And if you want to try it out with the premium subscription, please feel free to contact our salespeople or our support, and we can also enable you this premium capacity for a limited amount of time to make actually your decision. So you, like mentioned before, you see this here on this premium flag. And let's take a look what is actually the input into this application. So here the bigger case has also quite a bit some runtime. It will take a couple of minutes. That's why I prepared this already with the calculation. So in total, we have 4 tables. We have the shipments table, the warehouse table, the network structure that is highly relevant, and also the transport costs. The shipment table is our main table. I used actually here on purpose the latitude longitude mode to make the table a bit smaller. Obviously, we also have the address mode where you type it in directly with the addresses. So the shipment table itself, we have a shipment ID that uniquely identifies a shipment. And then we need to know from where does a shipment come. Additionally, I added here one additional column that is not a relevant column for the application, just to make sure if it's a shipment for the car or for the truck production. Then we have actually here the location name. So this I just used here our suppliers. And then for sure the latitude, longitude actually of the supplier. What is important is here this layer concept. Because that it's easier to model the network structure, we have a possibility to group multiple suppliers. So all the suppliers I group now into one layer. I have here multiple layers of the supplier because then I can use this later on in the network that I, for example, only allow a certain group to ship into a specific hub, for example. That's why you can hear multiple layers, but the idea of this layer is that you group multiple suppliers together. The same thing then for the to location. So where does the shipment go? And our shipment goes always in the factory, either in the car or van factory or into the truck factory. And this is then here the to layer. Then what is actually new compared to other applications is now with this period concept, we have the possibility to model this time-space network. That's why we have an earliest pickup period, a latest pickup period. All these columns I will directly explain in the small example because they can also maybe change something. Then it's easier to understand, but it just mentions here when can I pick up a certain shipment and when do I have to deliver it. And there's also a certain flexibility in there that the optimizer has the possibility to actually make certain consolidations decision. Then we have the weight, volume, and pallets like you are used to from other applications. In my example, I always just use the weight. Besides, let's quickly jump directly back to the map that the shipment, which locations are actually defined here. So the location of our suppliers here, this is all done with the shipments table, right? Because we have our from column, this will result then actually in this layer in the location from the supplier, and the to column we actually have then here our factories. So now what I have additionally is our warehouses. And these additional warehouses, or it's actually part of the network, it could be in a multi-echelon. You could also have central DCs and regular and local DCs. You could have multiple types of them. These are actually defined in this second table. So our warehouse table, you define the name, also the location, and then again, you define a layer that you can reuse then later for the modeling. Then we need to specify what are the handling costs and what are actually the storage costs. Handling costs and storage costs can be defined per per the same unit, weight, volume, and pallet. Just make sure that this is per weight unit. So this handling costs would be extremely high in a real world example, because it would be, if you are using kilograms, it would be now 50 cents per kilogram, what would be extremely high for the handling costs. In the other example, I also use a smaller configuration. Then beside the handling costs, we also have the capacity that we can consider. So how many units you can actually handle in one period. This is actually defined then here. And we can also define actually the storage capacity. So how many units you can actually also store. Now we come actually to a really important table. This is actually the network structure, because the network structure defines which lanes are actually allowed. Like I mentioned, we have here a combination between direct shipments and indirect shipments. So if I take a look quickly back, we have this approach, the direct shipment we allow, and also the hub and spoke. Let's take a look how this is actually modeled. Here, we are allowing from all supplier groups to all factories a direct connection. So this is done with this lane. So this direct shipments are done here for the cars and here for the trucks. The indirect shipments, we have two legs, right? One leg is from the supplier to the warehouse and from the warehouse to the factory itself. So this is defined here. And as you can see, even if this is quite a big modeling example, I only have here like these 17 or 18 entries in this network structure. And I directly define all the lanes with this table. So here, it's actually really important that we use then this layer concept, because these layers are actually allowing us to make this in a really small way. I just wanted to mention, if you want to allow, for example, from a specific supplier to only, for example, from supplier 1, I want to allow a direct shipment to this factory, then I could also use the location name itself. So you don't have to use the layer. You could also, for example, do something like this, right? If you just directly, so 1 second. Why did I not copy this? Sorry. You could also do something like this, that you actually model it from a specific, from location to a layer. And then you would, for example, only from supplier 1, the direct shipments to the car factory. And from the other groups, you would still allow it. If you would do it like this, then you have to model really many edges in here, but it gives you actually the flexibility to also adjust it really individually. This is the network structure and the transport costs. I will not go into detail because here we have quite some lanes. So you can actually model here. It's also with this layer concept. I will show you this then in the smaller example, how it's done. The only topic what I want to mention here, we modeled here 3 different truck types, right? We modeled a big one, a medium one, and a small one. And both of them have the different lead times and so on. But that's why the table is pretty big in this example. I want to show you this then actually in the smaller example. Okay, let's maybe go quickly to the small example to make this more visible and easier to understand. What I actually did, or what I actually want to explain you, is this the dilemma between, okay, do I go direct or do I consolidate it first? And therefore, I just picked out 2 shipments. These are these 2 shipments, and I can mention this already, but we can also open it in a map. Give me 1 second. Let's just connect these 2 shipments, and let's run the calculation. The suppliers are actually located in the south of France, and we need to route this. So let me quickly show you the map that you can understand how I narrowed down the problem for now. So what I took out is I just took 2 shipments. This means we have 2 suppliers in Spain. And we are only taking a look now at the truck factory in this example. So it's for suppliers for the truck factory. And because they're in the south of Spain, here the hub in the south of France is relevant, right? So when we are shipping actually these two shipments, it makes sense to consolidate them first in the hub and then route them actually together. And in this small example, I can also explain you now this time period concept and what is actually happening then in the output or in the result. Let's quickly take a look at this output from this one, and I explain you the output table, because the other output table can be there's quite a lot of output. In the output, we have actually 6 different tables. And the first table is the shipment overview. I only have 2 shipments, and here you can see then in the shipment overview what were actually the costs of the shipment. And here I made on purpose now an example where we have also storage costs and also handling costs for sure, because we are routing it via a hub. This is actually visible here in the shipment overview, and in the shipment details, you can actually see then exactly for each shipment what is actually happening. Let's take a look at this shipment here, for example. This first shipment, and let's see why do I have actually 3 entries in the shipment details. Because the first thing, what is actually happening, let's quickly go back to the map. Let's check, is this supplier, the supplier 52. We go from this supplier here to the hub. This is one leg, and then together in the second leg. And this one we can also see here in the shipment details, but we can also see one additional line, and this is actually the storing of the shipment in the warehouse itself. So the first line is this first leg. Here you can actually see it was picked up in period 1, and it took us 1 period to deliver it to the hub. And then we actually stored it in the warehouse for 1 period from 2 to 3. And the combined shipment was only actually done in the 1 day actually later. So the optimizer decided to bring the shipment to a hub, store it for 1 day, and on the next day, it makes more sense to drive it together with another shipment that is actually available. So this kind of, this is actually only possible with this time-space network, that you make actually also these timing decisions. And I also want to show you, now I jump back to the input. I mentioned before, I will explain you this periods here in detail, why this is actually the case. The first shipment that needs to be picked up in the first period, so on Monday. The second shipment is only available on the second day and until to the third day. So that's why the optimizer decides he has to pick it up, bring it to our consolidation hub, and then he is actually storing it. The earliest delivery period and the latest delivery period, this is here the same. So he has the possibility to ship them later out together, right? And this is why he made this decision to bring it actually to the hub and to store it. Even for sure, this is actually also resulting in some costs, right? So now we have the costs. 1 second, let's go back. We have then costs, what we can see here for transportation costs, handling costs anyways, and also for storage costs. Yeah. So the shipment detail, you can see, like I mentioned here, really in detail what is going on, how was it shipped, and each of this costs element is explained here. Then the third output table would be drop shipments. In our example, we don't have a drop shipment. This means a drop shipment could, for example, happen if I, for example, have now some period set up that I cannot match, or maybe I also don't have enough capacity to handle everything. Then this shipment would actually land in the dropped shipment. Now let's take a look. Additionally, we can also have then an additional output table. These are actually the transport outputs. So here we see all transports that were actually necessary to fulfill the problem. What is actually here quite simple. We just needed 3 transports what are actually exactly these three. So these two yellow lanes and this purple lane here. These are our three transports. And here on the transport, you see then also again the costs and also the utilization and so on. As you can see, especially the second leg has quite a good utilization, because there we fill up the truck because we are loading both of the shipments on one truck. The first two legs are not that great because we don't have any other shipments model that he can actually consolidate it with. So this you can see in the transport output. And then we also see in the warehouse output, there you can see how much handling costs are actually produced and how much storage costs per warehouse. But I think what I wanted to also show you, this table here, especially the shipment and the shipment details, if you open our dashboard, I would really recommend you to use the dashboard. And here I've jumped now on purpose. I skip these first two charts because they are only really relevant for the bigger example. What is actually new, we have here this transport details, and here we combine actually in one table the transport overview and the detail, because you have here the possibility to directly click on such a transport, and then you directly see which shipments are actually on which truck in this case, right? So you have the possibility to open this here and see actually all the relevant information. So this is helpful if you want to analyze your trucks. So you can for sure see the utilization and see which shipments are on there. And additionally, the shipment details. So this is what I actually wanted to show you too. Here you can also see how is a shipment routed through the network. Here you can also expand it, and then you can actually see, okay, this shipment, it should go from the supplier 52 to the factory. And this is actually done with two legs, right? You see this then here in this overview case. So I would really recommend you use the dashboard to analyze your results so you can filter the shipments. Here on top, this is a new kind of table that we introduced, and you can also take actually directly with one click then a look at the details. For sure, you can do the same thing in the Excel output, but then actually we would have the problem. Yeah, it's a bit more convenient to do this actually in the dashboard. So what I want to show you now is how much money do we actually save through this consolidation. And how we can actually provoke this is the following topic. What I did here in preparation is the following. I just copied, 1 second, let's bring this real quick up. What I did, let's assume what happens if we are doing only one shipment, right? What is our optimizer deciding there? So it's like I mentioned, it's really easy example, but I think it helps to understand this consolidation idea behind. Now, I use actually just one shipment to route it through. If I open now the map, let's see what the optimizer is doing. He ships it now directly because only one shipment, there is no second shipment where I can consolidate it with. So it's better to ship it directly. Let's quickly analyze this. Why is this actually happening? If we take a look, and now it gets interesting in the cost structure. In our small example, I made the transport cost quite simple. I only have one truck type of one capacity, right? We have 3 lanes that we define here. So the first one is from this one supplier to the hub. The other one is this one, and this is actually from the hub to the factory. I made it on purpose that the costs per distance units is all the same, and the lead time is actually the direct shipment has the 2 days lead time, and the combination, if you go first the indirect way, you have 1 day and 1 day. So in total, it will be also 2 days. So I did this on purpose that there is no problem with the lead time and the costs. But let's take a look now. I prepared here the output of this one shipment. Let's quickly take a look at the costs, right? With this one shipment, we have total cost, just transport cost, because there's no storage, of 3,964. If we do the same thing for the second shipment alone, we have a cost of 3,854. If we do both together, the output, then we have a total cost, we have a total cost here of 6,421, right? And if I add now the single cost together, I would come to a total cost of 7,800. This means I have now a saving here of 1,397 through actually the consolidation. And this is achieved because if we take, so it's obvious also quite clear in this simple example, right? If we take a look at the map again, it just makes more sense because the distance that is actually driven in the consolidated way, the total distance is also actually shorter with the same cost, because I have here a detour because I go from here to here and then first to here, not directly, but this second leg I drive them together actually with one truck, right? And that's why it's actually in this case less expensive, even if I have some storage costs and I have additionally some handling costs, right? But the savings of this long way that this is actually consolidated together is less expensive. So yeah, here I just wanted to make this really clear with this small example, which kinds of decision are actually done in the case. Okay, let's maybe then quickly jump back to the agenda. Also, based on the time, maybe quick question in the round. Are there any questions that I should pick up in the bigger round right now, or can we continue actually with the big example?
No questions at the moment.
Okay, perfect. So in the bigger optimization example with this use case, I actually showed it to you already. The output is here a bit more complex, right? So like mentioned again, we have all the shipment overview. Here I don't want to go in the tables in detail. What I actually want to show you is actually the dashboard of this output, because this is definitely much more interesting if you have a bigger use case. So now here in our dashboard, we can see that in total, we optimized 300 shipments. We see then also the total weight that was a shipment through. And in this example, we don't have a storage costs. So we didn't store anything, because most likely there were so many shipments or multiple days that there was always a possibility to combine them, that there was no need for storage. That's why in the small example, I on purpose enforced this storing in a warehouse, but in the big example, this was actually not the case. When we take now a look here at this donut charts, we can see actually how many transports we have in which transport type, right? The transport types are listed here, and then you can see actually the percentage. So most of them in the same transport type is here then, for example, this direct shipment of this transport type. Here we can see the same thing based on the cost. And I think what is quite an interesting chart is here the utilization of our vehicles. In our, it's actually not a utilization of the vehicle, it's actually the utilization of the transport mode. Because just keep in mind, a transport mode can be a vehicle, but could be also a container or air freight shipment. And here you can actually see then on each, so this, for example, is a good example. So here we have a utilization of 94% of this transport type. And the lower ones here, these are actually transport that were still needed, but they have a pretty bad utilization. So here, so if you want to achieve a good result, everything should be obviously up here with a good utilization. And here the x-axis is actually just the distance. So for sure, it makes more sense to focus on the longer transport, because most of them are then also more expensive. This should just give there an overview about this distribution. Here again, the transport details, you have really the possibility to take a look at each transport. So this transport is, for example, was only transporting one shipment, right? But I also prepared here then, for example, if you take now a look and filter it, for example, down, then you can now see, for example, here, a shipment that was from the location from one hub to the factory in Word. And here you see then that these two shipments were actually transported on this one. As you can see, these are now exactly the same shipments that I just picked for you in the small example, right? But here was also in the big example was the same consolidation actually done. The only thing what I changed in the small example, I fine-tuned a bit the earliest pickup and delivery point that I actually could enforce for you this storing in the warehouse. So this is what you can actually do here. Then further down in the shipment analysis, you can actually see then, for example, how many shipments were shipped with two legs. So 36% was done with an indirect shipment, and 63% were done with a direct shipment. Because sometimes just it makes more sense to go direct, especially if the shipment is so big that it nearly fills up your transport. It makes no sense at all to go via a hub first. And then here is again this shipment table, what I showed you before, where you can actually see then how a shipment was actually routed. So this is actually more interesting for the shipments that were done with two legs. There you can also see then the separate steps, but I showed you this already before. The warehouse analysis, this first chart shows how much weight was actually stored in the warehouse. And in our example, we don't have one, but 1 second. I can also show you the example of this dashboard when we actually store something. Then you can actually see here in period number 3, we stored 6,935 kilograms. So this was actually the small example what I just showed you. Then this is visible here. But for sure, the bigger example here, it makes much more sense to take a look at the handling capacity. So as you remember, we have a maximum handling capacity of 200,000. So the network is not fully utilized, right? There was always enough capacity in the warehouse to that you could actually handle additional goods. So this is actually shown in these charts. And here you can switch then on top just between the different warehouses to actually analyze here this outputs. Okay. So, and then finally, so this is the result of the dashboard. So I would really recommend you use the dashboard to analyze actually and to understand the shipments, especially if you solve this bigger examples like we did here, right? It is quite complex otherwise to analyze it in the Excel itself. So that's why we try to make this dashboard as much user-friendly as possible. Okay, then maybe let's quickly go also take a look at the output of the map, right, of the final map, just in comparison. Let me quickly open. This is the result, how it looks like by default, right, where you also have all this setting. So the only topic what I did here is I just added there these additional icons that it's easier for you to see from where the locations are. And if we enable everything, then you can see actually all the connections. But also here, I would recommend you to enable actually the different legs that you are just interested to see step by step on its own. So this is actually then all the result. So overall, to sum it up before we come maybe then to your questions if you have any. So let's quickly go back to this overview slide. So what is definitely important or new in this application, we can make this decision over the multiple time periods. Like you saw in the small example, we have the possibility to store goods in a warehouse, and let shipments wait for a certain time. That we can actually achieve this consolidation, for example, on the next day. So this time-space network is here definitely new. And like mentioned here, also we have the possibility to model really different transport modes. What I just did not do in my example, so what you can also definitely do if you want to model an import case from China, and you can, for example, model container shipments with sea freight and air freight shipments, this is actually also possible to do this with this application. And then the optimizer will find out for you the best optimized result. There is maybe one recommendation what I can definitely give you. I would only really model the necessary lanes, right? If you, for example, take a look at our map again, if it makes, from a practical perspective, makes, for example, never sense to consolidate here from this supplier something in this hub here, then I would also recommend you to, in the network modeling, never allow here this connection, right? Because this, to first bring it to this hub, what makes geographically no sense, I would really recommend you don't even allow it in the network structure, because this makes it already much easier for our optimizer to find actually the best solution itself. So this is maybe what I definitely want to recommend you. Try to make it with your network structure in a way that you have a realistic example, because this will also help you by the solving time. There's maybe one topic what I totally forgot to mention this time. I mentioned it, I think, in the 6.0 release. In the calculation area, you have now the possibility to define the solving time. The solving time can also take much longer than in other examples because of this complexity of the time-space network. You can define here the maximum solving time that you allow for the solver. By default, it's 30 minutes, but you can also go up until 1 day. And here it's important to this relative MIP gap, right? This means that here you tell the solver, okay, if you find, the solver can calculate a theoretical optimal solution, right? And if he finds, for example, now a solution that is 95% in the best area, then this would be a MIP gap of 5%. Then the solver can actually stop with the calculation. For sure, the solver is always trying to find the best output. If you take, for example, a look here at our super simple example, then you also actually see that here we have an achieved MIP gap of 0, right? This is so the best optimal solution that the solver could find, but it's also quite simple to find. It's because it's such a small example. But this I wanted just to mention, that you have these two additional parameters that you can actually also configure here. Yeah. Okay, so these are actually the topics just out of my mind, what I wanted to show you about the application. So let's quickly check if we covered everything. I showed you the result in the output of the dashboard. We made again a deep dive in the automotive use case, right? And now, are there maybe any questions, or maybe also a question to my teams? Did I forget something that would be maybe also important to mention in this round? So looks
So
like
no questions at the moment.
so
A
far so
couple
good.
of, yeah.
Yeah, okay, perfect. And I hope I didn't forget anything, right, that we wanted to show. I think this is yeah, all what we wanted to show about a shipment flow optimizer. So just to let you know, you will also receive soon an additional application for a second webinar if we take a look at our supply chain designer. This is the second application in the premium tier that we introduced in the 6.0 release. There we will also have an additional deep dive session where we also will show you in detail what you can actually do with the application. Yeah. Okay, perfect. If there are no questions anymore, then thank you for your time and have a great evening.